Hello everyone, thanks for coming. I appreciate on such a short notice that you guys took time out of your day to come here and see what I have to say and kind of listen to the discussion. I hope that by the time we're done here, you'll look at the world in a completely different way. Because right about now is the time in human history where we really need to start looking at the world in a different way. We don't live the same way as we used to, yet we're still using old school methodologies to govern a 21st century world. So, again, my name is Douglas Millett. I am currently the CEO of the company I started called Cybernative Farm Systems. I'm not really here to talk about my company too much, but if anybody has questions later on, I can go into details on that. I'm a former space shuttle systems engineer. I was based out of Houston, Texas, not too far off from the Johnson Space Center. I effectively worked with the Boeing people in the Boeing building on the Boeing stuff. Although I didn't get a Boeing paycheck, I was a subcontractor with another company. The space shuttle program was largely populated by subcontractors and contractors. There are much less actual NASA employees that worked on the space shuttle than all the contractors. I'm also the author of Turning Point, a book about space exploration and development. Which I wrote just because it's my passion. It's something that I've researched ever since I was a kid. I got into space geekery in general from Star Wars at the age of 8. And I have been basically along that path ever since, pursuing my engineering degree in engineering technology space systems, which is basically an applied aerospace program related to systems engineering concepts and designs. So, what is it about space exploration and sustainability that brings me here today? Well, I think sustainability is a very important keyword that a lot of people are starting to use these days because we realize we've only got one planet. And if we keep going along these detrimental cycles of consume, use, waste, then we're not going to have much of a planet left to live on. Go back, 10,000 years and that really wasn't so much of a big deal. Big world, or so we thought. But it's becoming a lot smaller now, and not just because of population sizes, because that's a factor, but not necessarily the lead determining factor. It's how we use, process, and manage our resources that's the problem. And so, when you look at space exploration, you're looking at a paradigm of thought that says we're going to a place that doesn't have a grocery store down the street. We're going to a place with limited resources. We have to maximize the efficiency of everything that we do, from generating air or water, how we process waste, how we collect and store energy, everything. Whether you're talking going up in the space shuttle for just 14 days, that requires a certain level of management. The ISS, the space station that's up there permanently, it gets resupplied every several months, so you're looking at month-long logistics of how long can we sustain ourselves for those until the resupply comes, or even more drastically, going to Mars, something to that effect, where you're looking at 2-year windows between resupplies on a planet that's tremendously hostile to, you can't just go outside and walk around and go to the creek and get a glass of water, things like that. So, each environment requires different obstacles that need to be overcome. Fortunately, a lot of the aerospace industry, the space exploration industries, have done the research on how to make these things happen. And if they didn't have a solution, they invented one. They came up with concepts and ideas that could be used to increase sustainability. So what we're going to do today is we're going to have a Mars-based thought experiment. You guys ever heard the term Gedanken experiment? Basically, a Gedanken exercise is a thought exercise. It's a German word for a thought process. I think it was Einstein that quoted that from what I remember. Doesn't matter. The point is we're going to do a thought experiment. We're going to ask ourselves, if we were going to build a Mars base, let's say it holds 10 people, 20 people, something of decent scale, not just 2 guys going with a couple of shovels and then they come back home within 30 days. We're talking about a longer duration. What kind of systems, what things do we need to account for? What are some of the important characteristics that we have to, all right, we've got to cover this, and this. If we don't, people die. Those are our biological needs. Those are the things that keep the human creature, the animal known as the human being, alive. Then you have your quality of life needs, things that make your life better. And there is a difference between just being alive and then improving your life. So there are like two different characteristic sets that you can consider. Most of us live in a world where we have one covered somewhat and a little bit, and the other one, the quality of life, as good as we can get. There are people in the world, as we well know, that have neither and are suffering and dying because of it. And so a question we've got to ask ourselves is, how can we possibly fix that? So we're going to ask ourselves, what are some of the biological needs that the human being requires? Anybody just throw one out there?
Food.
Food, yes. Food would be one.
Oxygen.
Air, oxygen, yes. Proper concentration of air.
Water.
Water, all right. Those are the three that most people jump to right away. Sleep would be another one. If anybody suffers major sleep deprivation, you suffer big biological detriment. It can kill you, it can drive you crazy also, things like that. So sleep deprivation, and also medical care. If you hurt yourself, you need to be able to fix yourself. If you're in a situation where you can't, you're dead. Infection or something like that. So that's a biological need, some kind of medical care. And that really, if you think about it over the course of human history, only recently have we really gotten good at the medical care bit. Because for the longest time, the smallest cut in infection would kill people. And then you go back to plagues and stuff like that, where something as simple as rats passing a disease because things were dirty. You know, you clean up the environment, you end up mitigating a lot of those health risks, and it allows people to live more quality, productive lives. So those are some of the things to think about. So basic necessities of life: air, food, water, sleep, and medical care. So we've got a list for those. All right, we need to take care of those to keep the astronauts alive on the base. Now we got to figure out how we're going to do that on a world that isn't exactly as nice as the Earth. Then you have this one: quality of life needs. Now some might say, well, how is shelter a quality of a life need, or what is it? Well, on Mars, shelter actually becomes a biological need, because you can't just live out in the open air on Mars. So for that location, shelter kind of becomes a hybrid of both. You need it to survive, because that's what's going to keep your environment secure so you can exist with all of the other biological needs that you require. Then you've got clothing, which in their case would be outside outfits and inside outfits. Education, having the proper background to know how to manage all of your systems, and also the scientific work that you're doing. But this also applies just in the regular world as well. The better your education, the better your quality of life. The more informed you are, the more you can contribute to a dialogue or to a discussion on any particular topic, as long as you're educated and informed. It's ill-informed opinions that come from ignorance, unfortunately, that seems to drive a lot of the media and slander and attacks and how politics works and things like that. It's quite disappointing from a scientific point of view. Energy, transportation, and communication. So, all right. That is kind of the thought experiment as far as, okay, how do we address these needs? How do we address our quality of life needs, and how do we address our biological needs? So now we're going to go through this thought experiment a little bit. But there's something to consider with all this. Sustainability in space increases sustainability on Earth. A lot of people ask, why are we spending money on space exploration when we have so many problems here at home, right? A lot of the problems that we have at home, a lot of the problems you have that are no longer problems wouldn't have been solved if it wasn't for space exploration going to the next level, challenging what we're capable of, looking at an environment with no gravity, or microgravity as the case may be, or looking at how do you get water so sustainable that it works and stuff. Well, then you end up inventing technologies to cover the crazy place, which actually makes doing it back home pretty benign, and you can help more people that way. So you solve a lot of natural problems that way. And another thing to consider is abundance. Having more than enough to suit the needs of a region. You can't have a shortage on Mars. You can't accidentally run out of something. You actually need to have more than you need for the group of people there, just in case. You have to have contingencies. It's called a lot of things in engineering and the sciences. It's called an overage, or it's called a percentage factor, where you have, we need X plus 20%, or something as a fudge factor. And if you think about how we operate in the world, it's by far the most important word with respect to mankind's ability to live peacefully on the earth. If I were to have all of you guys on a deserted island, and there's one coconut tree with 3 coconuts on it, how long do you think it would take for what you guys probably think are relatively peaceful, understanding people to lose your minds over getting the coconuts? When the human body is stressed and there's a limit to the resources that it needs to live, we act like idiots. And we got to live, right? So you will kill somebody, you will rob somebody, you will do whatever you can because of the negative environment, because of the lack of abundance, or scarcity is the word. That bad behavior will manifest because of that scenario. However, if I have the same group of you and we have 500 coconut trees, that there's so many of them that when one of them gets plucked, there's another one that's everything's ripening. Well, now where's the issue? Are you going to fight over coconuts? They're everywhere. So then the behavior calms down. You're more cooperative. You work together. You cultivate the coconuts as a group. You learn how to store them and stuff like that. Protect them from the weather. It becomes a different mental thought process. So abundance of your biological needs and your quality of life needs can drastically affect how human beings interact and relate to each other. And if you look at human history all the way through, if anybody does a real serious analysis, they will see that one of the most common drivers of conflict is a scarcity of something somewhere that people need. And so they fight over it. Now people say, well, that's human nature. We're just violent. No, that's human behavior, and that's highly modifiable. You can make somebody behave a bad way if you put them in a negative environment. And vice versa, you can turn that around and make them positive in a positive environment.
Like that psychological exercise where they made people, they tricked people into torturing other people by simply having a person that was fake, and on top of it, a fake military guy standing and saying, yeah, you tortured that guy, or we're going to torture you.
Yeah, there's that, and then there's the scientific experiments where they were giving shock treatments and they were getting paid money to do it. The person on the other end was actually faking being shocked, but they would still do it because of the influence of there's a reinforcement factor that can affect people's psychology. And we're learning more and more about that. The social studies, the psychological studies on how the human creature actually works, not how people think we work. Because you always see in the media, you always see all the bad stuff. So people are like, well, human beings just suck. So we've got to put all these rules and laws and things and control and all. No, not really. A baby isn't born being a bastard, all right? A baby is born not necessarily as a clean slate, because there are genetic predispositions to certain behaviors. But we're learning that those are turn off and turn on switches. And if put in the right kind of environment, there's a less likelihood that the bad stuff will manifest or the good stuff. It depends on the characteristics. So we're getting a lot better at understanding how the human being and the brain and all that works. But we're still kind of applying archaic methodologies to just blanket statements. That's just human nature. That's how people are. And when you're on a Mars base, you can't afford to have astronauts fighting each other over resources or something. That would be ridiculous. I mean, what's the point of the mission if they're going to kill themselves anyway? So you got to look at the ability to produce an abundance with minimal human labor input. That's what technical abundance will do. Because you don't need your astronauts being farmers all day long, or just spending the majority of their time and energy maintaining their habitat. They need to be out there doing the science and the exploration that they were sent there to do in the first place. So what you want to do is you want to highly automate and make less human labor intensive as many of the aspects as possible that give them the comforts that they need to exist. And so then the question becomes, why don't we do that on Earth? So let's look at some of the technologies for biological needs, some of the things that exist. I do have a source sheet. I don't ever say anything technical that I can't back up with sources. So if you're interested in getting a hold of the source sheet, I try not to print anything to kind of save paper a little bit, go on that eco-friendly route. If I can send it with electrons, I'd much rather do that. So give me your email address and I will send that off to you. At the end, we'll do that at the end. So, air on Earth. Well, that one's pretty covered, as long as we don't pollute it all. And that will be addressed as we go along down the line and we look at clean energy solutions and things like that. We've really got to stop doing the caveman thing of lighting things on fire to provide us with energy. There are other ways of doing things. Water, we have desalinization plants and they're getting much more robust. Local rain collector facilities, centrifugal centers, and for example, there's a magazine that NASA publishes called Spinoff, and you can look it up online. It's a free online publication that talks about all of the technologies that either NASA directly developed or that NASA contributed engineers to a private industry or something like that to develop a technology. One of them is portable nanomesh that creates safer drinking water. And there's also the Water for Life bottle out there where it has a mesh in it. You can dump the water in the dirtiest stream you've ever seen, and you push this thing down, and out the bottom, or actually it's the other way, out the top is perfectly clean drinking water. You drink it straight out of the bottle because of the nanomesh that's inside of it and stuff like that. So there are solutions out there to fix. Where's the water shortage? There's really no water shortage. What we have is the inefficient system of getting people what they need so that they can live. It's an efficiency issue more than anything else. Food. High-tech farms. I think using a hoe and a plow or a tractor to dig in the dirt and take out massive amounts of land is kind of feudalistic, don't you think? Especially in the 21st century. We have hydroponics, we have aquaponics, we have the ability to grow things without the need of soil. There are plenty of places in the world that have arid, dead land. And the reason why they're starving is they can't grow anything. Now people say, well, why don't they just move? It's not always that easy. If that was the case, everybody's going to congregate in all the primary cities, and there's already a congestion of people in the primary cities. And if you get too many people stuck together, you have one little disease or one little cold, you have an epidemic, you have a problem. And so why don't we just make it more efficient so you can live anywhere you want on the planet but still be able to get food locally? So local production, local distribution. CFS, the company that I've created, that's basically what we're dedicating. That's what I'm dedicated to, is building fully automated buildings that are 464 square meters. I'm putting it in your terms because I always forget I'm in Europe. I almost always go to feet. 464 square meters. I can feed 1,600 people, 10 different fruits and vegetables each, off of a building that is completely run on solar and wind power, collects its own water. It doesn't need an infrastructure. I can drop this building in the middle of the Sahara Desert. Its robots do all the harvesting, computers, it's climate controlled, it's got a fish farm built into it because it's aquaponic. It's a closed loop, ecologically sound system, and it will run for 50 odd years. And you can put this building anywhere, which means you don't have to have the logistics issue of shipping people food, or what we do today. We grow something over here, but we spray it with a bunch of chemicals so that we can then pick it early, put it in a truck, send it to the grocery store, or get it out around the planet, and then when it gets there, spray it with another chemical so that it'll ripen so it'll look pretty on the food stand. Yeah, chemical A, chemical B going inside human seed. Not so good in the long run. So it would be a good idea if we could come up with less chemically dependent ways of dealing with food. And the organic food movement is working on that, but you run into this issue. If you're not doing it as efficiently as possible, there's not enough land on the planet to really make that realistic, unless you go hydroponic and aquaponic. And I prefer aquaponic because it's completely natural. You don't have to use any chemical fertilizers. In hydroponics, you still have basically liquid fertilizer that you pour into the system. And a lot of that is still petroleum-based and things like that. Aquaponics, if you just look it up, you can see what it's all about. But it's basically fish waste feeds the plants, and then you can run it through a filter system, and the clean water goes back to the fish. And the fish eat food that actually is also grown in the same system, so it's all close loop. You don't have to add anything from the outside to make it work. So you would want something akin to this, maybe not necessarily the fish bit, because that might be a little difficult to transport fish all the way to Mars. That would be interesting. I'm not saying it's impossible, but that might be a little bit more, a little overkill at the beginning. But you could do hydroponics and take the chemicals that you need. And you've got sleep. Well, that comes a lot easier when you're stress-free, when you have a full belly, and you don't have to worry about your breathing conditions and stuff like that. And in the space industry, that's highly regulated anyway. There are really no such thing as late nights in space. You're not up partying and stuff like that. There is a regimented schedule of when you go to bed and when you wake up and things like that. So that's highly manageable in space. On Earth, you really wouldn't have to worry about that so much, but a lot of people today lose sleep because they're stressed. They've got to go to work and get the kids to school, and where's food? I got to go to this job that I probably hate. Do this work that's probably boring me to death, because I can't afford to go do what I really want to do with my life, but I've got to pay the bills so I can live. Medical care. It depends on what you're taking with you. Large-scale robotic systems might be more complicated, but that thing that you see on the left is called the Da Vinci machine. That's a doctor inside a little cubby where he's got his hands on these little controls, and he has a 3D glasses and a look, and he can do really fine surgeries. And it's becoming more and more popular, and it's also a lot safer. The incisions for heart work, cardiac work, and some other works have become tremendously safer. The recovery times have dropped 60–70%, so a person can have a major operation and be out in a week versus a month. There's drastically huge differences in letting a robot help you do it because of the fine-tuned nature that a human being just can't really accomplish in most respects. There's still a human being there, and you can do this robotically, telecommunicatively. The doctor doesn't have to be there. The doctor can be elsewhere and still do, thanks to the communication age, which we'll get to in a second, they can just do it online and operate online and do what you got to do and save somebody's life. And the astronauts typically would have a PhD going on the mission anyway, a doctor, a medical doctor. So you would have something like this. So if something bad happens, you're in a lower G environment, you're at 1/3 gravity, there are certain conditions involved, or having something like this would be highly advantageous and probably make things a lot easier. And there's a lot of medical research that goes on in space as well that just helps us learn about how the human body operates in space, and if we can learn how bone density goes down or why bone density goes down when you're in orbit, maybe we can if we invent the solution to fix that, who knows what that might fix. That might be a bone cancer treatment. We don't even know yet. They're what I call accidental successes. You're on this path of solving one problem, and then in the process of solving that one problem, you realize that you can use that to solve 2, 3, 4 other different problems, or they contribute to something else. So another industry will say, well, yeah, but we can use that for this. It's almost how the MRI and the CAT scan machine came about, because that was an Apollo mission thing for scanning the skin of the Apollo craft. And they realized they could use it to scan people and be able to detect defects. So now you got technology for quality of life needs. All right, what do we got? Shelter. Now let's think a little bit more about Earth. What can we do on Earth? Because in space for shelter, you're going to have the pod that you're flying in, and it's going to have the landing craft. Or you might send a couple of missions in advance of drivable tubes that would land all within a certain region, and then you could robotically have them all congregate to a particular location, and then when the astronauts get there, they just have to do the little bit of driving at the end to put the Lego pieces together, and you've got yourself a little base. So there's ways to pull that off. That would be more like a 7 or 8 or 9 year mission plan to send some logistics ahead of the crew, and then send the crew. Well, how could you do stuff on Earth? There's a technology out there called contour crafting, developed by a doctor, a PhD of engineering at the University of Southern California. And what this is a robotic gantry that you can see on the left. That's a model of it, that's the concept. All right. What you see on the right is an actual working smaller scale system. It can build based on the speeds that he's got, he can build a 2,000 square foot house in 24 hours. Because he's literally 3D printing it, if you think about it in that way. It runs around and it drops a layer of wall, and it lifts, and it drops another layer of wall, and it lifts. And because of the material that the wall is made out of, it dries fast before the robot comes back around to the next pass. It can drop rebar, it can drop plumbing, and it can do electrical. So you've got this setup that could be tremendously useful in, say, I don't know, Haiti. I mean, when Haiti happened and the earthquake struck a couple of years ago, you had huge displacement of people. Ramshackle shacks that just fell apart because they were obviously ramshackle. They weren't built very well. And so how easy would it be to drop 2 or 3 of these robots and literally cut out a neighborhood in a couple of weeks? You know, clear all the rubble, recycle as much of it as you can, crush it all up, and put it back into the system. And try to recycle as much of those resources as you can. But they're still living in tents now. You got contractors trying to bid on who can get paid the most money to go in and build these neighborhoods, old school style, with a whole bunch of people, a large infrastructure. Oh, we got to ship all these things. No, you need that, one of those. And it's not all cookie cutter houses that look exactly the same. You can program, this thing does complex geometry. You can program into it virtually any kind of house style you want. So you can make a neighborhood of 10 different housing styles, and it can just, every other house will be a different one. And eventually, so you'll have a customizable neighborhood where people will have choice. Or, if you think about it in a future context, wouldn't it be nice to design your own house, at least rough scale, what you have in mind? Let the computer make sure that it's architecturally sound, and then this system is built for you. Wouldn't that be cool? Then you've got the smaller version of 3D printing. So say you want to print your clothes or automated sewing systems and things like that. Or you need to print your textiles like cups, plates, bowls, silverware, or whatever the case may be. Like, for example, this building. How many people of you are familiar with 3D printing? Okay, so for those who don't know what it is, 3D printing is literally taking a block of plastic or resin or whatever, putting it in a machine, and in one fell swoop it makes that. Complex geometry, you can do some pretty amazing things. You'll see the video on the source sheet that I have that shows you it's a mechanical device that has spinning gears that all interlock, and when you spin one, they all spin, and it's really cool looking, and it's really complex, and it was all cut out of one block. It's not a whole bunch of separate parts put together. The printers are getting that good. So we're getting to the point, I won't quite say Star Trek replication, because that's a whole nother level of complexity. But we're at least getting to the point where you can almost print on demand what you want, instead of the current mode, which is make a whole bunch of something and hope people buy it, right? Have a warehouse full of stuff and do marketing analysis to say, we think 1 million people are going to buy this product this year. And then you just hope that it works out that way. And in a lot of cases, the people might be settling for that product because there isn't one out there that's exactly what they want, but they find one that's close to what they want, all right? Whereas with this kind of a system, you could make what you want, submit it to the local production system that's in your neighborhood or in your city, and it will manufacture it and send it to you. So you can literally get what you want. Again, the height of personal choice. Education. Institutions like this are age-old, they've been around for a while, but we have internet learning. The keen example that I use is a website called the Khan Academy, K-A-H-N Academy.org. My daughter uses it, she's 8. We put her on it actually when she was 6. And she was 6 when she did this. I had her start doing some of the math. The 1 and 1 is 2, 2 and 2 is 4, yada yada. You go through these modules, it's like a tree. This Khan Academy on the math side of things goes from literally 1 and 1 is 2 to advanced trigonometric calculus and derivatives, integration, things like that, trigonometry, geometry, everything in the middle. It's this big tree. As you pass one thing, it opens up doors to other things. But it's self-directed. You can go however you want. And each lecture is, or each module is accompanied by a short 10-minute video just about that small subject. It's not overtly dynamic to where it can lose you. Every video is only like 10 minutes long or less. It gives you the hardcore concepts of what you need to know. And then you can start doing the practice questions. And you can do them over and over again. And for kids, they win badges. There's all kinds of little fun, interactive things that they can do. So I've got my daughter on it. Her name is Angelique, and I've got my daughter on it. She's doing it. And maybe I'd say 2 or 3 months into it, because I don't monitor her. I just say, go do Khan Academy for 30 minutes. We homeschool her, so that's her lesson. That's her math lesson for the day. Go do your Khan Academy, and then we'll do some reading after that, and we'll learn about a civilization. We'll do a Google search, and we'll look up history or something like that. And so she comes to me a little bit later on in the day and she goes, Dad, I need help with a word. What does obtuse say? And I'm like, huh? Obtuse? She goes, yeah. And then she runs off. And I'm like, obtuse? There's only one obtuse I can think of. And that goes with acute and goes with right angle, as in triangles and trigonometry. So I'll walk over there and that's exactly what she's doing. She's doing right angles, she's doing obtuse and acute angles, she's already passed the module on radians versus degrees and stuff like that, all because she took a path that took her down to the intro of trigonometry. So she's one step away, at that point she was one step away from starting to do a squared plus b squared equals c squared, you know, doing Pythagorean's theorem and stuff like that. She's 6, all right? Never tell a child that they can't do something. They can do whatever the hell they want. As long as they drive themselves and they're interested. Well, that's what the Khan Academy does for people of all ages. There are older people. You can study economics on there. We'll talk about that. There's math, there's sciences, and they're trying to get history. Some of those subjects are a little more dynamic than just like maths. You know, math, there is an answer. 1 + 1 is 2. You know, things like that. Some of the history is if you want to do writing assignments or something like that, that's a little bit different. So, anyway, the education dynamics have become very, very robust. And the beautiful thing about this is since it's internet-based, since we have satellite communication technologies, which, we'll get to that in a second. Since we have communication technologies and things like that, we have put ourselves in a place where you can learn anything you want, anywhere in the world, no matter where you live, as long as you can connect to that information source. The world has never been in a situation like that before, where anybody anywhere can learn anything. They just have to have access to what they need to enrich themselves and to make themselves better people. What we have more on this planet than anything else is an access problem. Now let's talk about clean energy. There's an access issue with this too. We have your solar, you've got your wind. The one on the right is actually a brilliant idea. Think about that. When the cars drive by, these are vertical. I prefer vertical much more than horizontal. Horizontal wind vanes are your traditional windmill style. Take up a lot of real estate. They're very big. Gravity's pulling down on it, so the gears on the top end wear out, so you always got to send maintenance crews up there to fix them. They break down, things like that. Vertical ones rest on a magnetic bearing base so that you can blow on it and it basically moves because they're floating on a magnetic field. There's no friction, really, if it's done the right way, or very, very minimal friction. So the wind cut-in speed is called the cut-in speed that gets the blade spinning. It's tremendously less, so you can have them spin in a breeze. They're not going to generate as much power until they really start getting up. But at 20 to 30 feet, because you put these on a pole, at 20 to 30 feet up, the wind is almost always cruising about 5 to 10 miles an hour if you're above the building line or above the tree line. But in this particular case, for these lights, when the cars go by, what do they generate? Boatload of wind. So if the car goes by and it causes these things to spin around, now you can power the lights that run the highway by the cars that go by on the highway. How efficient is that? So, and plus you've got natural wind, this is going to blow through, so you're going to be able to have this constant lighting system that has 0 impact on the environment because it's all wind-based, it's just built in. Now what if you had something like solar roadways, which I don't have a picture of, but you can look up a company, it's called Solar Roadway. They've literally figured out how to make roads their own solar panel collectors you can drive on. And they're made out of a certain glass, but they don't freeze over like people were afraid, well, how's a car going to stick to it and stay on it? And they've already tackled those hurdles. Imagine being able, you want to give messages to people and they're driving. You can put messages in the road by illuminating lights so that people can see the messages in the road or something like that. Slow down, wreck ahead or something like that. People would be able to see it. And if you went a step further, you could put piezoelectric sensors in the road. You know what piezoelectrics are? Basically, you generate electricity through vibration. Well, what happens when you drive a car over a bridge, for example? The bridge vibrates. Well, if you make the road so that it vibrates a little bit, which most of them do anyway, and you put piezoelectric sensors inside the road, along with the solar collection capabilities, you have one hell of an energy collector. All the cars that would be driving over it would be able to generate electricity. Yeah.
They've already tried that one in Japan on the train stations, where people walk. So I guess
It's ideas
Cars-
in test.
cars.
Yeah, there's a lot of ideas that are in testing phase right now. Just concepts. They just kind of make you think, wow, if we put enough of these in there and we did it the right way, we could generate an abundance of energy. To go back to that word abundance. Then there's this guy, the Bloom box, which is an amazingly efficient fuel cell box that's dominantly made out of sand. And you can look this up at any time. So fuel cells have come a long way, and they're a lot smaller. And then you get to something like transportation. This right here is the Ultra system. It's in test right now in Heathrow Airport. It's an automated tram system, the car that drives itself. And you just hop into it, and you press where you want to go, and it pulls out, and it takes off. Because you got to ask yourself, when it comes to transport, what do you want? Do you want a car? Or do you at least just want to be able to go where you want, when you want? Okay? People say, well, I want a car, because that's if you want to go where you want, when you want that right in your garage. So you spend $40,000, I'll put it in US dollars, $30,000 to $40,000 on a vehicle that you drive about 25% of the time. Because if you look at it statistically, your car is parked, doing nothing for 75% of its life. Kind of a waste of resources, don't you think? Which is why certain nations, and I think Germany is doing it, and I know they have a system going on in New York right now that they're testing. It's a car share program where you can check out a car almost like you would at a library. And so that car is constantly in use. It would pull up and a person would get out, and then another person will be able to go and hop in and go where they need to go. All right? Now, if we got those solar powered and clean energy powered, or whatever the case may be, you would have a very special transportation system. But it's not a one size fits all. It's not everybody doesn't need a car. And you have cities like Stockholm have an amazing mass transit system. A lot of people there don't even have a car because they don't need one. Why? I experienced it when I was there visiting for the past few days. They come so often, the trains come so often, that you're not waiting more than a few minutes before you hop on and go where you need to go. But if you were to drive, you're going to get stuck at red lights, you got pedestrian traffic. I mean, you're probably going to get where you need to go faster using the mass transit system than you would if you tried to fight downtown traffic. So it depends on where you are. Now, if you're driving to the countryside, obviously you're probably going to want a personal vehicle to carry your stuff and your luggage and your family and stuff, things like that. That's where a checkout system, almost like a library book, would be highly more efficient. I won't say renting a car, because that's a different kind of concept. So just something to think about. And then you've got your electric cars. I just think Tesla makes some really sweet-looking electric cars. I mean, you've got the Nissan Leaf. The Prius is a hybrid kind of a concept, so it's not quite there yet. But we're getting there. There's a vehicle called the GM Skateboard. It's a concept vehicle where actually all they build is the base of the vehicle. It's a fuel cell driven vehicle. And you can put any body type over the top. And it's all electric, which means you can put the steering wheel anywhere, in the middle if you wanted, in the back. You could sit in the back, you could sit in the front. You could make it a pickup truck, you could make it a car. I mean, it's so dynamic. If you wanted to, you could just look up on YouTube, just put in GM Skateboard, and you'll be able to see a whole Science Channel review of it. It's an amazing technology. Then you've got this, Stanford University. It's a fully automated GPS-controlled car that drives itself around. And they're getting better and better and better at programming it so that it behaves, not quite AI, but at least understands the rules of the road and can get itself around. Are they ready yet for that to just show up and pick you up at your house and you just hop in and say, take me to the store and read a book while it takes you to the store? We're not quite there yet. But the concepts are there and our technological capabilities are there. If you were able to put radar systems on it and have an infrastructure in place in the city where you could have relay stations, you could set up a very robust automated driving car system. Again, you don't really need a car, you just need to get around. And then you've got, for long duration, maglev train systems, which are relatively well known in Asia. They go hundreds of miles an hour. And if you did them, there is another thing out there called ETT, which is electronic tube transport, or evacuated tube transport, sorry. Basically, it's about the size of a car. It's a tube that you sit in, and it's inside of a tube, and they suck the air out of that tube, which reduces your drag. So that means you can go 1,000 miles an hour or 1,500 miles an hour in this tube. And if you built the infrastructure properly, you can go from New York to LA in 45 minutes to an hour. You would accelerate slow, but your speed, your top end speed, you'd be flying, and then you decelerate as you get to the end, but you're going so fast as you can read a book and watch a TV show and you're there. We don't have those systems in place because the car industry right now is so strong with you need to own your own car, that concepts like that kind of get laughed off the table, even though they're perfectly viable. We need to stop doing that. Communication. We all know about the communication age. Everybody's got a phone with apps and da-da-da-da-da. You can pretty much do anything you want except cook your breakfast on the phone. You can almost cook your breakfast on the phone. So, if nothing else, you can turn on and off your vehicle. I'm surprised you probably could turn on and off your toaster if you wanted to with an app. So, we definitely have no shortage of communication capabilities in the 21st century, the likes of which we've never had before as a human species. I mean, we've gone from smoke signals and yelling at people to being able to text, and I Skype with my wife and daughter every day. I'm in Europe, well, Scandinavian Lecture, Northern Europe, for crying out loud. As long as we work out the schedules, we can talk to each other, we can see each other. I can interact with my family in a way that go back 10 years and try to explain that to somebody. That you can live video chat with somebody on the other side of the planet directly. They'd be like, right. Now, it's hard to think of us not being able to do that. It's amazing as you get immersed in the technologies that make your life better, that you forget that it didn't used to always be that way. Which is why I like addressing young people more than anything else, because it's you guys are the one that are going to take these amazing capabilities and make the world a better place. So, after such abundant solution sets are implemented, there's a question to ask. Can the current socioeconomic system that we live in now actually handle such robust global sustainability? Is it designed for that? Is our current OS, is our current operating system for the planet, think of it like Windows 1, is that capable of running the software that we have today? If you tried to run anything on Windows 1 right now, it wouldn't work. It's not capable. It's not upgraded. It's not advanced to the level of our capabilities. However, if you think about it in terms of economics, we're using systems that were invented hundreds of years ago. We're still using some of the same systems. But we don't live in a world that's anywhere remotely close to when those ideologies were invented. But there's still a lot of people today that defend them as if they're still relevant. But they're not. So we can do an analysis. The current socioeconomic system versus global sustainability. What do we have now? We have a system based on scarcity. We go back to the coconut tree. All right? What is supply and demand? What is the market? What are those things really based on? They are based on haves and have-nots. I have something you don't have. You have something I don't have. In the early days, it was straight up trade and barter. And then proxies were invented, which eventually, seashells and jewelry and things like that. And eventually, we just came down to good old-fashioned money, right? As a way to manage the market of have and have-not. What we need is a system based on abundance. Because as I've shown, with all those previous technologies, we have the capability right now today to create an abundance of clean air, water, food, shelter, clothing, textiles, transportation, energy, communication, all the things that we need to live amazing qualities of life, which can free us up from the drudgery of going to jobs that we don't like, or not being able to get the educations that we want to pursue, or being afraid of losing the roof over our head, or afraid to not be able to feed our kids their next meal. There's a lot of fear rooted in how we operate in this system. And of course, when you live underneath that kind of a construct, sometimes you get a lot of bad behaviors built out of it. What do we have now? A system based on inefficient human labor as the main driver. Well, what do we need? A system based on efficient technical labor as the main driver. Because A lot of what I just showed you is highly automated. But a lot of our system is based on humans doing the work for other humans. We're running into a disconnect, especially if you look at automation and robotics in industry and manufacturing, or in virtually anything. Machines, sorry to say it, are just better than people in many, many different ways. They don't need cigarette breaks, they don't care about a paycheck, they don't need food. What they do need is energy. But I already covered the energy bit, didn't I? You have solar, you have wind, you have geothermal, you have space-based solar power, which is still a theoretical concept, but is getting stronger and stronger developed as time goes along. You've got fuel cell technologies, you have you have wind, wave, tidal, all these different concepts. It's not about one holy grail energy source to satisfy cold fusion, to power the world. Okay, if that happens, that's cool. But you don't need that. What you need is a robust, dynamic energy system that is made up of all of them working together. All of the clean energy systems working together. But it's all still rooted on human labor for income. You've got to go to work and submit yourself as a tool, labor tool, whether it's a mental tool or a physical tool. Do a job to satisfy some need and get paid for it, and then you use that money to do what? Buy your food, your shelter, your water, your clothing, all the things that you need to live. If you live in a world where the technical capabilities are so strong that a lot of that can be provided in abundance for basically the rest of mankind's existence, what's the point of the human labor construct when it comes to that kind of a system or that kind of capability? It's about capabilities. A system based on cyclical consumption for constant growth. We always hear about that. The economy's got to grow 1.3%, or it grew 4%, or 2%, or whatever. And a system based on sustainability and balance. As we were talking about before the lecture started, how many planets do we have? How many Earths do we have? Cyclical consumption and constant growth. We don't have a spare Earth to pull from. And a lot of people are starting to realize that now. Good. Because it's important to realize that you can't just keep growing economically, because by definition, by today's world, economic growth means more manufacturing, more selling of goods, more consumerism, which means you're consuming more resources. The problem is the way the current model is built is you're trying to maximize your profit as much as possible, so you generally make the crappiest stuff that you can so you can cost efficiency, so that you can sell enough of it to make more money, to make the shareholders happy, or to fatten your wallet, or whatever the case may be, cover your overhead, or whatever. How much waste are you generating just in that process alone? When, if you wanted to do it the smart way, you would make the most highly efficient, highly sustainable product possible. That would last 100 years, and the only time that things would need to be replaced would be internal components, and you would make sure that you design the future systems to be compatible so that you unplug one chip and put in the next chip. I use cell phones as an example for that. There are really only a couple of designs of cell phone that really matter to most people. Ergonomically, our hands are only so big, and our thumbs can only do so much. So it's between touch screens, which allow you to skip the whole need for making a keyboard, versus the slider phones where it does have the keyboard built in. There are only probably about, what, 5 to 7 different designs of a phone. You don't want them too big because those become pads, and that's a completely different concept. And you don't want them too small because then you can't see anything and your fingers are too pudgy and you can't press all the buttons. So there is a range for human need for a phone. However, look at how many different designs of phones there are out there. And we're talking subtle differences, just so Ericsson can sell something that Motorola doesn't have. So they can find some market niche. How much wasted resources goes into that? Think of how many billions of tons or millions of tons or whatever of rare earth metals are chucked by people who get rid of a crap phone that they don't want anymore to try to get something else. And where does that stuff go? Most people don't recycle it. So it goes into a waste landfill. Those resources could be recycled, reused, or if the system was developed properly, you would never replace the entire phone. You would replace the software in the phone so that it would be better, or if they came up with the faster chip, they go from 4G to 9G or whatever G they decide to invent next for more speed, then you would basically take out the old one, put in the new one, and voila, what have you wasted? You didn't throw away a whole phone, you have a chip. And that chip, if it's done right, could also be recyclable. You could break that one down into its constituent parts and be able to reuse those resources to make the new chips, or maybe in something else completely different. We don't operate that way. We need to start operating that way. We have a system based on ownership and control. This is mine. I own it. And what we need is a system based on usership and open access. How does that concept work in reality? Well, ownership kind of makes sense if you go back a couple of hundred years, especially when you have a lot of human labor going into making something. That's a lot of work, and you don't want to be taken advantage of. So you want to own your farm, for example. It really kind of basically started with the advent of agriculture. Because prior to agriculture, what did we have? Did we really own anything? Go back 50,000 years, what were we? We were hunter-gatherers. We barely stayed at any one place long. We constantly shifted and moved. There was no need to own anything because you weren't there to protect anything. You just kept moving along. They actually had natural abundance. There weren't enough people on the planet to put a strain on it, so wherever you went, as long as you stayed along a creek or a river, you could find foods and animals and things to hunt and ways to live. Quality of life wasn't that great. Medical care, you can snuff it relatively easily if you break a leg or do something like that. Okay, and not a whole lot in the way of shelter or protection from the elements or protection from the wildebeest that wants to kill you or whatever animal's out there that doesn't like you very much. So the quality of life wasn't too high, but the ability to biologically live as far as primary things of need were in abundance. Well, then we got into agriculture where we started hoarding and controlling food supplies, and I own this farm, which means I got to put a fence around it because I don't want somebody coming in and stealing the food that I've worked for. And so you start developing this mine mentality. We still have, unfortunately, we still have this mine mentality. But we live in a world that's so capable right now where the labor input is not a person, it's a machine. And the machine doesn't care what you do all day. You know, a robot doesn't care, say my farm systems. The technology in that farm building doesn't care if the people that it feeds are playing Xbox all day or if they're an astrophysicist examining the root structure of the universe. The robot doesn't care. A human being might care. People will say, I don't want to work and have some lazy person, you know, get what I've worked for. And they say, I'd rather somebody who's earned it to get it. Well, that makes sense if you're doing humans serving humans. That kind of breaks down when you start looking at technology serving humans. Dumb tech. I'm not talking about AI. AI is a completely different animal. The moment we get robots to think and behave and react like a human being, as far as I'm concerned, at that point, they should be treated like a human being. They are not a slave labor force. They should be given the same rights as a person once they've established the ability of AI to be that strong. Because by all accounts, what we've then done is given birth to a different life form. It might not be a carbon-based life form as we are, but it'll be a life form. But that's getting a little bit off topic, sorry. Usership and open access. Going back to the car thing, do you want to own a car or do you just want to get around when you want to get around? If you have an infrastructure set up that's tremendously robust and is effective, you don't need to own the transportation system, you want to use the transportation system. It goes a lot along the lines of online sharing. And there are, obviously with SOPA coming up, you know, I don't know how many people are familiar with SOPA and all that, it's in the news a lot. It's basically the internet piracy ban that they're trying to do in the US. Yeah, in the US. And trying to basically lock down websites that they feel are questionable, while that's highly open to interpretation. And that can go down a bad path really fast. And, you know, if you say anything against the government or whatever, they'll just shut you down. Or a corporation doesn't like what you're doing, they can shut you down. So that really becomes an issue. And I think the internet is scaring a lot of the people who have maintained power and control for so long. They're seeing the internet and the open sharing of information, and people your age and my age who are like, just have it, here's information, take it, you know, do something amazing with it, help somebody with it. We're open source, we're open access, we're open information. We are Linux. The world used to be Windows 1, and we are Linux. We're upgrading. So it's time we start upgrading everything. You got a system based on outdated, multi-century old ideologies and institutions. What we need is a system based on forward-thinking adaptation and emergence. Things are always changing. Just because we have a rule today about something, let's even take physics, sciences, the hard sciences, right? They're always questioning themselves, and they should be. Sometimes they don't, but that's economically driven in a lot of ways if you think about who's funding research and things like that. But science is supposed to always question itself. Is E equals mc squared still valid? Is it? And then ask the question, and then attack it, and see what happens. And if it still holds valid based on the knowledge that we have today, then okay, we'll run with it for a little while longer. And then 20 years down the road, we might learn a whole bunch of new stuff, and then we'll ask, is E equals mc squared still valid? Do we do that today with our economic system, with how we operate the planet, with how we manage our resources? No. We've always had money. Leave it alone. We need to have a trade. We need to have a market system. There has to be a free market. We need a free market to manage the resources and human labor and yada yada. We don't live in that world anymore. So we need to upgrade and change. And we need to install an operating system that is designed to upgrade and change as we get better. It should not be stoic. It should not be standard to where, not standardized. Some things are good to standardize so that everybody's communicating on the same page. You know what I mean? But it has to be emergent. When we learn something new, we reflect and we say, okay, how did we do it before? Now we have new data. Fix it, make it better, make it more efficient, and then move forward. That's what you do in the sciences all the time. It's so funny how some of the defenders of the current way the world works don't realize that the technologies that they use, their phones and their computers and all that, were developed, if those systems operated on the same ideology that the planet does, they would have never been invented in the first place, most likely. Because you don't question things, you leave it alone, you don't change. You stay in the cave because it's scary outside. What we have is a system based on hostile competition, secrecy, and differential advantage. I have something you don't have, I'm better than you, I hold sway over you. I've got to keep my ideas secret because somebody could steal them and make money off of it. And a hostile competition, I'll explain that in a second. Then you've got a system based on cooperation and collaboration of ideas for information for mutual benefit. So that goes back to cooperation, collaboration, working together to make sure that whatever the problem is, we have the right people with the right brain, right mental set to solve that problem as quickly and efficiently as possible, using the smallest number of resources as possible, maximizing the benefit for the entire human race. Yay, that's solved, move on to the next challenge, regardless of what that challenge is. Let's go build a space station now. Or let's build an underwater city so that people have another choice of where they could live on the planet. Or a floating city that just kind of moves around like a big cruise ship, but it's huge and it just kind of floats around. There's so many other problems, so many other things that we should be challenging ourselves with. How people eat and get their energy and have shelter and manage goods and services should not be a problem that we are dealing with. We're better than that. Well, as far as hostile competition goes, I'm all in favor of competition that's friendly competition. Two scientists jokingly or friendly-wise going after each other. You know what, I'm going to solve this problem before you. No, you're not. I'm going to kick your butt. All right, let's go. In the end, it's still good for everybody. Why? Because the problem's going to get solved. As long as the scientists have it in their mind that at the end of the day, they still shake hands and go have a beer. Right? It doesn't really, it's friendly competition. Sports. You know, a lot of people sometimes get a little bit too pacifistic and be like, oh, in the future we need to be less violent. We need to not have these violent sports and stuff. Ladies and gentlemen, testosterone is not going to evacuate the male species in the future. We still have, there are biological things going on there. So a good game of rugby or football or American football, so I'm going to separate the two, or whatever, those are good because at the end of the day, does that hurt anybody else? Now the football game itself, the two guys might be crashing into each other or whatever, but they're voluntarily doing that. They know what they're getting into when they play that game. But at the end of the day, is anybody starving to death by them playing that sport? Is anybody lacking of shelter? No. However, economic competition in today's world kills people. And I don't care what any economist says. Economic competition kills people. Because if you really think about it, Africa is probably the most obvious example of a pillaged, raped, and plundered continent for its resources that other entities can use for their benefit in the name of economics, in the names of selling products, but the people who are getting screwed the most are not even able to benefit from what's happening. That kind of competition kills people. And we need to stop behaving like Neanderthals when it comes to that. Right now we have a system where political opinion, influenced by financial contributions, dictate the ebb and flow of global operations to benefit a select few. Anybody follow the Occupy stuff? The Occupy movement? 99% and 1% and that whole big fight that's going on. I mean, it's a statistical fact that, you know, the majority of wealth of the planet is basically controlled by a very small percentage of the population. It doesn't seem very sustainable to me. What we need is a system where the scientific method is used in conjunction with human experience and technical foundations to enhance the lives of all people. We need to grow up a little bit. And prior to all of these advances in technologies, we really didn't have the tools. We didn't have the right tools in our hands to grow up in the way that we needed to. We were still basically feeding off the bottle. We're still infants in diapers, you know. If you really look at the whole of human existence relative to the life of the planet and the universe, we're babies. And we just now we're getting to the point to where we can see that there is a light at the end of the tunnel now. Hey, you know what? We actually could do things for the mutual benefit of all people. Not differential advantage where I have mine, good luck getting yours. Go get a job. You know, go get a job and work and whatever. How are you supposed to go get a job when there's no jobs out there? And the reason why there's no jobs out there is because it's more efficient to use technical systems to get the job done than it is to use people. The entire basis of the paradigm crumbles. And that's some of the problems that we're seeing today. So mankind needs to move to a new and upgraded global operating system, most commonly referred to as the resource-based economy, which uses, the general practice is simple. All of the technical solutions that I talked about are basically increases in the efficiency of management of resources. Resource-based economy. That's basically all it means. But remember, no utopias. No such thing as a utopia. That's an ideological concept that's usually used as an attack. You're talking utopia. Everybody's all happy all the time and everything's perfect. I'm not saying everything's perfect, but it can sure as hell be a lot more efficient. Again, I go back to this 50,000 year ago hunter-gatherer. I want any one of you to go back in time 50,000 years and try to explain to a hunter-gatherer what a house is, indoor plumbing, and a car. Do it. Try to explain to that person how you live today, to things you take for granted today. Guaranteed that person would be like, well, not guaranteed, don't say whatever they communicate, but basically they think you're nuts. Crazy. First of all, they're probably not even concepts that they would even be able to rationalize. But they would probably say, that's utopian, come on. I get to live in one place all the time. And no matter if it's hot or cold outside, the inside is the temperature I want it to be. So let's not talk about the thermostat, being able to climate control your home. And I can turn on a tap and I can get water. Anytime I want. Hot or cold. Whatever. Yeah, you guys are nuts. See, it's all about, you gotta think, how were things done then, how are things done now, how could things be done?
Projections.
Projections, that's a good word. We project this insult on making things better. In a weird kind of way. It's very self-defeatist. That's utopia. No, it's not. It's just better, more efficient. Are there still going to be problems? Yeah. There's always going to be problems. There's going to be work for people to do. The difference is, are they going to be working on what they have to work on just to make money to survive? Or are they going to have the freedom to work on exactly what drives them the most? Their internal passion. And they have no boundaries of an educational limit or a resource limit as far as how to live, where they get their energy from, or any of those things. If you have that kind of level of freedom, where all of your biological needs are met, and your quality of life needs are met, to a reasonable standard based on the knowledge and technical capabilities we have today, then you are free to be exactly what you want to be in the world with no restrictions. That might seem kind of utopian. I just think it's pretty kick-ass. I would still be an aerospace science geek wanting to go build space stations. There are others who would love to be artists. Long gone would be the term starving artist, because nobody would have to starve anymore unless they wanted that experience. Some artists actually do want that, so they want to be really low so they can dig in deep into themselves. It's almost, meditative, ritualistic in a way. But if they wanted to do that, fine, go live in the woods for a couple of weeks and see how long you last. You're really going to find yourself in that situation. You might have an epiphany and be a better artist and come back to the real world where you can live in your studio and paint and sculpt or whatever the case may be. But you don't have to worry about where you're living or where you get your next meal or things like that. No more homeless. No more crimes of scarcity. People who don't have enough will do anything they can to get some. And then you've got crimes of power and corruption. People who have a lot and just want more because they still want to control and maintain an influence over others. So think about how many crimes are monetarily based. Because money is the governance of the resources in today's world. You need to have money to get the resources. That's the access medium. That's the proxy. Think about how many crimes are monetarily based versus how many crimes are just crimes of passion. Statistically, it's how much crime would go away if people didn't have to fight over that kind of stuff. And it requires a different mindset too. It requires a different level of thinking. You've got to get past the mind. You've got to get to the hour. You've got to get past what I call selfish self-interest. We all have self-interest. We all want to live as creatures. We want to be alive. We have self-interest to preserve ourselves and our families, right? But do you have selfish self-interest? I'm going to get for me, good luck for you. Or you're going to have selfless self-interest, which means I'm going to help everybody, and I know that that's going to come back to me because everybody's sharing the same mutual paradigm. In the end, we're all going to go up. All tides rise, all boats rise with the tide. I can't remember that saying off the top of my head. But everybody comes up. So which world do you want to live in? Where you collaborate and work together and everybody comes up because it's all open source, there's no hoarding of information, there's no secrecy. A development in China is instantly shared around the world so that everybody has the technical capability to 3D print that technology so that every city and every house has the capability of upgrading themselves all at the same time, or at least within a couple of months everybody has access to it. That'd be pretty sweet. And then we run to the next challenge. How can we make it better? How can we make it more efficient? So, new tools and capabilities require new ways of thinking. We go back to the hunter-gatherer concept. And then we're simply moving from an established society to an emergent society, one that constantly adapts and upgrades as we learn more data, because we never stop learning. That's what keeps us going. We're always learning. And if we're done learning everything we do on the surface, then we go study the oceans, or we go study space, or we go study another planet. We just keep challenging ourselves. What can we learn out there that might be able to improve us even more? There are no final frontiers, really. You just keep going. So, transitioning. Very, very important question I get a lot. How do we get from where we are now to that kind of a world? How do we move to that kind of a thought process? Well, do what you love, but do it in a way so that you're always thinking not about profit and making a whole bunch of money and a 10,000 square foot house and a bunch of chicks and a fancy car and all that stuff. Very materialistic, monetary mindset. Think about it of how can I use my gifts, my talents, my passion to better affect the world, myself, and my brethren. And that's the whole human species. All right? And do it in a nonviolent, peaceful, helpful way. Nothing will hurt us more than if we continue to keep attacking each other. I used to be of the mindsets not too long ago, a couple of years ago, where I was still very much an angry man. And it was a product of the whole 9/11 thing, go kill the terrorists, go get the bad guy. It's also very an American cowboy kind of, you know, cowboys and Indians go eye for an eye, tooth for a tooth kind of stuff. That's how I was raised. You are a product of your environment. And so it's taken me, I'm not that person anymore. I've grown up a lot in the past few years just by a lot of internal reflection. I didn't like the path I was going on. And so we all need to start adopting that better path of, you know, it's not so much eye for an eye. It's why does that person feel the need to behave that way? What is going on for them that's so screwed up that they want to kill or attack or whatever? And how can we mitigate that? How can we stop that? How can we get in there and give them food so that they don't have to fight for that? They see somebody helping them instead of constantly kicking them. How can we be better people as best we can? So there are a lot of groups and organizations out there. This is a small list. There's Open Source Ecology, the Zeitgeist Movement, the Venus Project, the Atlas Initiative Group, and many, many others. So corporate social responsibility companies, social entrepreneurs who are starting, that's a key phrase that's coming up a lot more. And in a way, it's very much rooted in a lot of what I've already talked about today. It's, we're screwing up the planet. We need to be more responsible. We're screwing up each other. We need to be more responsible. We need to be socially responsible, ecologically responsible to ourselves and to everybody else. So find a group that you like. You don't have to like these, you can find something else. Get involved with a bunch of people who think the same way you do. Start a group, start a company, start a for-profit, start a non-profit. Do something that you can take these ideas and push them forward and start helping people, because we're not going to do any good if we're all just a bunch of cyber warriors online going, man, this all sucks, and here's all these solutions. And then we sit there. I hope somebody does it. Get off your ass. Go do it. That's what we need to be doing. That's why I'm starting the company that I'm starting. Go do it. I don't like the current system. I'm stuck in the current system. I have to use the current system because there's really not a whole lot of other options. It's a lot easier to start a company than it is to start a nonprofit, at least in America. It takes about 2 years to go through the process of starting a nonprofit. It took me 4 days to establish my company. And you can do the entire thing online. So it's, you know, I'm doing what I can so that I have created this corporate socially responsible entity, so that I can save lives, help people, use 21st century technologies to show people that no, robots aren't going to take over the world. It's dumb technology that's going to make you food. It's dumb technology that's going to be on top of your roof, that's going to make your house completely off the grid so that you never have to pay a light bill or electric bill for the rest of your existence. And any future person who lives in that house is going to have the same benefit. And if we can get that everywhere, then we have a dynamic electric grid. Some people accuse this concept of being communist, socialist. Everybody, it's all centrally planned and controlled, right? No. This is about local production, local distribution, not central plan, central control. This is about dynamic equilibrium. And if anybody's familiar with engineering principles or scientific principles, or even if they're not, they can look up dynamic equilibrium. It's an ebb and flow adjustment that benefits the entire system. So for energy, for example, what if every single building in the network, in the city, let's just say the city is a network, had its own partial energy creation capabilities? What do we have now? We have the height of centralized when it comes to power. One power station, maybe two if you're lucky, but most cities have one, a nuclear plant or something like that. What happens if that goes down? Everybody's screwed. The entire grid goes down. If a relay station goes down, that's shifting the power to a different zone, that whole zone goes down. All right, think about Florida when hurricanes come. All the power outages that they have and stuff like that. In houses that aren't really damaged, but because somewhere else a tree fell on a power line, which shouldn't even be above ground anymore, because that's ridiculous, and you live in a place where trees can fall on power lines, everything should be subterranean. But that would cost too much to put the power lines under the ground and all that stuff, and using better cables and stuff. So what if every house was its own partial contributor to the grid? And then when, like, say, a skyscraper or something like that, which has photovoltaic windows and photovoltaic paint and has all these generation and storage capabilities built into this building, and it's currently generating 150% more power than it needs because everybody went home early for the day. All the lights are off. And it's also highly automated so that when you walk in, the light turns on. And they're all LED lights. They're low power 1 watt or 5 watt, really bright, awesome lights. So you reduce your energy load. And then when you walk out of the room, after 10 seconds or whatever, they automatically cut off. So there's no chance of some idiot leaving a light on all night long. All right, so those are standard everywhere. Every home, every building, every location has that as a basic, that baseline. So you have less use, more generative capabilities, and if you do have a building that's running a higher load, what's going to happen? If the grid is computerized and automated in the right kind of way, that 150% energy is going to get filtered off to the building that needs it, and it's going to create a dynamic equilibrium. They're going to basically feed the excess to the system that needs it. And then if the entire grid is generating more than it needs, then you store it or you filter it off to other local areas. There are ways to make those things happen. It's not that hard to do. We're not doing it, but it's not that hard to do. That's the kind of world we could be living in. That's the kind of world that is about global sustainability. That is the kind of world where science, engineering, and technology is used for human concern. Thank you. Questions?
Don't be shy. Whatever pops up in your mind.
It's okay if you don't. It's fine. It's a lot to absorb. It's a lot to absorb.
Questions before like I mean, some things are just I mean, you can talk about it getting people to change, but getting people to change, that's like you gotta spend a lifetime to change, really change one guy.
I think it's, if you look at it in
unless that
way,
guy, you're holding that guy on the top of a volcano and you're planning to drop him.
change. No,
Yeah, exactly.
We're not doing that. Non-violent, no volcanoes.
Volcanoes are violent.
All right. You don't worry so much about changing people, you change the system. You change the conditions under which they live. Eventually, the bell's going to go off. Think about it this way. Person makes a whole bunch of money, or whatever, and they got to pay all these bills. But then you help them get off the grid with whatever company or institution or organization. You get them off the grid, so now they don't have a light bill anymore. Right? No more power bill. Yeah, you've got more money, so you can go spend it on a cruise or whatever. You don't have to pay electricity ever again because your house is off the grid. All right. Now you install in that same city a food production facility that is so robust that he could do a one-time cost and have access to that food facility for 50 years because he's not buying food, he's buying the production facility. That's what CFS is doing. That's what my company is doing. People don't buy food from me. They buy the food factory, and it's a one-time cost. And because it's sustainable and off the grid and runs itself, all maintenance and stuff is covered by us. If something drastic happens, we're covering that free of charge. I'm not interested in fleecing people for money on maintenance contracts. I'm interested in feeding people. So you put in a one-time cost, and now you have access to that building for the rest of your life. So now you get those all over the place in the city, right? So now he doesn't need to spend money on food anymore, because that's over. So energy, okay, food, okay. Then you set up transportation systems. You understand, you see what's happening here? Money is becoming less and less relevant. Why? Because he's covered this base, now he's covered that base, and eventually he gets to the point where he's got all this money, he's going,
what am I going to spend it on?
what the hell am I going to use this for? And when the only thing that would be left would be like recreational stuff or human-to-human services. I want to get a massage or something like that. Okay, well, think about it. Why do you pay the masseuse? Because the masseuse needs the money to go and buy food, shelter, whatever, whatever. Well, what happens if the masseuse has the same kind of life that that guy has? The electric is covered, now they've bought in that food building. Now neither one of them have a monetary need to live. So now it's just like, well, now it's just service for service. You give me a massage, and I happen to be a landscape artist, so eventually it's going to come around. I'm going to help you do your lawn or something like that and make it all snazzy or whatever, or I'm a pool guy and we'll insert a pool, or do something like that, which could also probably be automated anyway. But there's these different concepts that now we're down to just recreation. Well, okay, why the hell can't recreation be free? If everything else is basically covered by technical abundance, by implementing systems over time that help make it kind of silly to need money anymore. It's not that money's bad or evil or anything like that. It's that it's not relevant once you start implementing these robust systems. The world can't flip today. People would freak out. They wouldn't know what to do with themselves. Couldn't do it. But you can erode over time the need and dependency for money.
Yeah, definitely. Now, and I agree that that is the most probable or the only way that's actually going to work, I think.
I do too. It's going to take a little
slowly and make these changes happen over time. The thing is, I don't think you always have that time. And I think that a lot of people, once you get people to, okay, they get their food for free, electricity and energy isn't a problem, transportation isn't a problem. What the fuck am I gonna do? There's nothing. What am I gonna invent to improve upon this?
Depends on the kind of person they are. They can do whatever they're passionate about.
And also, I mean, you talked about how many we are in the world today.
Mm-hmm.
I mean, how can you? Or you can't, but if you try and imagine this system, how many people do you imagine could theoretically live in this system without it being overcrowded?
With regards to population, and that's actually a question that's asked often, and then I'll get to you because I saw you have your hand up, so I'll get to you right in a second, and then you. We'll go around. Do you have to leave?
Yes.
Oh, okay, go ahead real quick.
Yes, I was wondering, does NASA have a crisis group?
Does NASA have a crisis group?
Yes.
I don't know. What do you mean, like asteroids are coming, everybody get together? And,
Yeah.
The government does have, you know, those kinds of contingency plans because obviously we know it can happen. It's happened in the past, but I don't know anybody on a board or anything. There are crisis prevention groups, and like the government can find out from NASA when natural disasters happen, for example. They'll use the NASA satellites to scope the area and see where the damage is and things like that. So that's how NASA kind of comes into play. They really don't have the people around the boardroom going, all right, we got to stop this asteroid, how are we going to do like Armageddon kind of stuff. There's not really that per se. But they do use NASA's capabilities when necessary, but that's more of a government thing, not so much a NASA thing. NASA's the tool that's used. They're not necessarily the instigators of the crisis control. As far as population goes, people need to realize that people say, oh, we're growing. We're just going to always grow. Actually, not necessarily. If you look at population growth, where is it strongest? Where are the population booms the most? Third world, impoverished, low-educated areas. They have a fertility rate of about 7 to 1. They're reproducing 7 to 1. Why? Well, because you don't know if your kid's going to live past the age of 10, right? Or they're so uneducated that sex is just something that they just do all the time. They don't have proper protections. The diseases are all over the place. So they're just constantly trying to reproduce just to kind of keep what's supposed to be a baseline level, but they're overdoing it. Why? Because their situations are terrible. If you look at first world nations, where life is okay, you're at about 2 to 1. It's almost a self-replication balance. A guy for a guy, a girl for a girl. Most families have 1 to 2 kids. Typically it's a boy and a girl, something like that. You have people who have no kids. You have people who have 8 kids. But if you look at the statistical average, it's about a 1-to-1 replacement. Why? Because they're busy, they're educated, they're doing things, they're engaging their minds. They don't want a whole bunch of kids, or at least they want a manageable family so that they can go do things, right? They have food. They're not worried that if their kid catches pneumonia, they're going to die. They just give them some NyQuil, tell them to be quiet, and go to bed. All right? If they get a cold. So it's a different environment in which they live, so you don't need to overproduce. Now imagine if the entire planet was at that high standard of living, where life was good, education was high, the freedom to travel, to learn, to get educated. You're going to see population naturally. I am not in favor of overt population controls. I'm definitely not in favor of killing off people or any of that nonsense. All that New World Order crap, conspiracy theory bunk. I can't stand conspiracy theories. They drive me nuts. But if you were to raise the standard of living for every man, woman, and child on the planet, you're going to get to a dynamic equilibrium. But if you have a stressed environment, we know what the ramifications are. So when it comes to population, could this system handle the population we have now? Oh yeah, we've got more than enough resources to do it. You have to account for how much we waste. If we were to knock off all the waste and started doing production more efficiently, we have well more than enough to cover the needs of the population and then some. At least until we get to a point where we start coming down and start finding that equilibrium. But also at that point, you've got to consider, where would people be living? You wouldn't necessarily always have to be Earth-based, would you? Can you imagine what the space exploration industry would be like if there was no budget, there were no budget issues or politics to get in the way? Because as you start eroding the need for money, and people start behaving a lot better, and people start committing less crimes because their life is better, government starts to dwindle. Because what's government supposed to do? It's like the law enforcement thing, right? They govern economics and laws to make sure everybody behaves nice. If you cultivate an environment where people naturally behave nice, government starts to become less and less relevant. So now you don't need them to make all those decisions because people are wise enough and educated enough to make them themselves, especially when they don't have to worry about food, shelter, water, yada, yada, yada. So we don't address problems the right way. We see this person is bad, put them in prison. It's kind of a federal thing, right? No, it's this person is bad. What environmental screw-up has made this person bad, and how can we fix it? And then once everybody's on the same level, if you still have somebody that goes and commits a murder, even let's say the world is the RBE, everybody's living great, things are going good, our cities are upgraded, things are going great, somebody still kills someone. We know it's not environmental anymore. Now we know it's biochemical. There's something wrong, it's a psychological problem, there's something mentally wrong with that person. Today, it's kind of hard to tell the two. You don't know if a person is crazy because they're crazy. They literally have a chemical, mental imbalance. They're biologically broken. Or did the environment make them crazy? And are they behaving that way because they feel that they have no other recourse? So they steal or they rob or they don't care about human life because nobody's cared about them. You know, there's a lot of neuroses and psychoses. But is it environmental or is it genetic? Is it natural? Well, if you're living in a world where it's pretty damn good and somebody still behaves that way, we know the answer is. It's not environment, unless something weird happened to that person, which is plausible, but that's where psychiatry, that's where mental doctors come in to help people get better. Find out what's wrong. If nothing else, we can medically figure out why people go off the deep end and maybe help mitigate and prevent that from happening in the future.
But then psychologists in those societies, not our psychologists.
Well, yeah.
Because our psychologists try to fix us to this world.
Yeah, they try to adjust people to
Adjust
abide by the current rules.
to the misadjusted world.
Right,
Alright.
you're right. That would change too. I'm sure the entire psychiatry and psychology field would completely shift into a different way if you're living in a world such as talking about. So that covers the population.
That is also a change that would happen periodically with the other periodical changes.
Mm-hmm.
As well.
Yeah, it would
Everything.
mold over time.
So, but what I was thinking about, you said you needed to erode the money system, and I also see that, or I would say that you need to erode a lot of fucking systems to even get close to this. I mean, the religion overall needs to be wiped out.
No, I won't go that far.
I would probably say you have to, because there's too much friction. There's too much. When
I'm okay
people
with
talk about their beliefs, they don't want to have people say, no, you're wrong. Because they don't want to be wrong. They don't
That's
believe they're
because
wrong.
they're
That
against
friction
social programming.
creates.
That goes to the my religion is better than your religion or that kind of thing. That's a
Yeah,
that-
exactly.
that's-
But that what's it always ends up in my religion versus your religion.
I know, and that's something that, again, that comes with education, doesn't it? I mean, over time, people...
It doesn't necessarily. Some of the smartest people I know are religious, but...
Are they accepting?
Well...
They accept religion.
I'm okay with religion if people are accepting of others' religions. And we don't live in that world right now because right now a lot of religion has money, power, and an influence.
Yeah,
That goes all the way
nice
back to Middle
influence.
Ages stuff. And that's still baggage that they're carrying. But if you talk to, I'd say, the average religious person, they're not holy warrior crusaders trying to take out other religions.
No.
So they have, I'm more of an advocate of personal faith.
They're-
Believe whatever you want. Believe in the holy chicken, as long as at the end of the day,
Or the flying spaghetti monster.
you know, so yeah, the flying spaghetti monster or Cthulhu or whatever.
Yeah.
As long as at the end of the day, you're a good person, you treat other people good, and your goal in life is to better yourself and others around you in whatever way that you can contribute to that.
Exactly, but that's why I mean you need to roll the religious system.
No,
because
you need to
it always
improve the
creates
educational
that,
system.
That animosity between people.
That'll manifest over time. Go ahead.
Yes, if I'm allowed to change the subject.
Sure.
I'm really interested in these autonomous robot farms. Where are they today? How far off in the future is a totally autonomous system?
Counter.
If I were to put a time frame on it, I'll have my research and development done in 12 months.
Oh.
Because right now we're in phase 1 development. In order for these to be off the grid, I can't use 100 to 500 watt grow lights. It's too much juice, too much power goes into that. There's no way I can be off the grid, wind, solar powered, sucking that much juice, because I need 200 of those bulbs. I mean 200 growth chambers inside this building to grow all the food necessary for that building to be sustainable. So right now I'm in phase 1 development of a lighting system that I've created. Now once that is done and proven, then after that, all the other systems exist. We know robotics exist. There are dexterous robots that can pick and do things like that. Those are all, you can find videos on YouTube about all that. It's all a systems engineering concept at that point. And that's basically where my contribution is. I don't know a whole lot about aquaponics. I tell people that all the time. I don't need to. I'm going to bring in an aquaponics expert. I'm going to bring in a robotics expert. I'm going to bring in a clean energy, solar, wind power expert. And we're going to get all these guys. I'm going to sit around a table, and we're going to have pizza and Mountain Dew and coffee. And we're going to design and set up and put together this system. And we're going to develop a prototype over the next, well, I figure about another month or two, I'll know if phase 1 is good. Then phase 2, I get the $1 million funding that I need, and I have connections and resources to make that happen, to build a prototype. Once the prototype is built, after that it's cookie cutter. Every building is effectively the same. It's the same process, the same software program. The robots are always going to do the same thing. The distances are always going to be standardized after that. So then you just start plopping these buildings everywhere. And I'm going to work with governments and institutions and humanitarian organizations and anybody I can, even private sector, who philanthropists and humanitarians who like, yeah, let's put 20 of those in Mogadishu or in sub-Saharan Africa or anywhere where people are starving to death. Let's get these in there. These can also be put in neighborhoods. Let's put them in a city area where an entire town can almost be fed off of one of these buildings, or maybe 2 or 3 of them growing different types of foods. Because there are limits to aquaponics. There's some stuff you can and can't grow. So we're not trying to grow everything. We're not, again, not utopian. We're not going to be able to grow everything. But I jokingly call it a salad factory. We're going to create a lot of leafy greens and herbs, vegetables, some basic vegetables, spices, things like that, different things that we can grow, so that people can at least have something. And then I will spend a lot of the money, the profits that I get for that, inventing new ways to grow more stuff. How can we grow short stalk wheat so that people can make breads, things like that. How can we get it even more robust? And we will figure that out over time. So I'd say I'm about a year away, hopefully less, from being able to say, we're ready to go. We just need to start placing orders, and then we can just ship, move, drop, save lives. Ship, move, drop, save lives. So that's how far we are out on the automated farming thing, because that's what I'm working with.
That's amazing.
Anything else? All right, well, thank you very much. I appreciate it. I appreciate your time. I appreciate you having me here at your university. If you do want that information sheet that I have, you guys can come up here. I have a tablet you can just write your emails on really quick, and when I get back to my laptop and internet connection, I will send you guys off that sheet. All right? Thank you very much.